If $500 is invested at 4%, compounded continuously, how long until the account balance is doubled? If you remember, the equation for an investment that is continuously compounded is S equals P times e to the RT power. Now, if we substitute the known information into the equation, we can solve it for t. So we want the balance to be 1,000 since we start out with 500 and we want to double it. So we set 1,000 equal to 500, which is the initial investment, times e to the 0.04, because that's the rate, times t power. So we're looking for what t is. What's the time here? The amount of years. So if we divide both sides by 500, we get 2 equal to e to the 0.04 t power. Then we're going to take the natural log of both sides. So if we take the natural log of both sides, the natural log and the e cancel out, leaving us with 0.04 t on the right and the natural log of 2 on the left. Then we divide both sides by 0.04, put this into our calculator, and we get that t is approximately equal to 17.3 years. If the half-life of an element is 35 years, at what rate does it decay? In this problem, we can use the same equation that is used for bank accounts that are continuously compounded, since the element is continuously deteriorating. So we have S equals P times e to the RT power, where S is the amount of the element remaining, P is the principal or starting amount of the element, R is the rate of decay, and T is the time in years. However, since the element is deteriorating, R rate should be negative. We don't know the mass of the element to begin the problem, but we do know that the goal is to find the rate that will make the element to reach half of its initial value p. We also know that the time is 35 years. If we substitute these values into our equation, we get 1/2 p, which is the amount remaining after 1 half-life, equals p, the amount we start with, times e to the 35 times r power. If we divide both sides of the equation by p, it simplifies to 1/2 equals e to the 35r power. Now we can take the natural log of both sides, that cancels out, and we solve. The natural log of 0.5 equals 35r. Then solve for r, plug this in your calculator, and we get r equals negative 0.0198, which means that the element decays at a rate of 1.98%. A bacteria grows constantly at a rate of 10% per hour. If there were initially 100 bacteria, how long until there are 1,000? Alright, so first we plug in all the information we know. We start out with 100 bacteria. The rate is 0.10. We're looking for the time, so t is our variable, and we want there to be 1,000 bacteria at the end. So we divide both sides by 100, and we get 10 equals e to the 0.10 t. We take the natural log of both sides. So when we do that, the natural log and the e cancel. We're left with 0.10 t on the right side, and we have the natural log of 10 on the left. Divide that by 0.10. Use our calculator to find that t is approximately equal to 23.0. It will take the colony 23 hours to increase its population from 100 to 1,000.